Hello, dear students. Today I will speak about the solubility rules because some of you have some problems in solving the homework number 7. Also, I am going to speak about the net ionic reactions. The general rules for the solubility are the following. Soluble ionic compounds are all the compounds from group 1A, lithium, sodium, potassium, etc. And beside that, you have ammonium also in this group. Then when you are in presence of a salt or a compound that contains one of these cations, you will be very sure that the compound is soluble. Nitrates and acetates are also soluble, and most of the perchlorates. Chlorides, bromides, and iodides are soluble except when they are paired with silver, lead, copper 1, silver 1, lead 2, or this ion from mercury. Sulfates are soluble except when you're in presence of calcium, strontium, barium, silver, or lead 2. All the hydroxides are insoluble and also are insoluble the sulfides, except when the cation is one of these from group 1A, and also ammonium, calcium, strontium, or barium. Carbonates and phosphates are insoluble, except for the group 1A cations, or also when you have the present ammonium. Here is a short representation of these rules. You can have this at hand when you're going to answer any exercise of this kind. Let's see. This is an example of the question that you had. Write the balanced net equation for the precipitation of manganese 2 hydroxide from aqueous solution. Then the final product will be manganese 2 hydroxide. That is a solid. As they say, that is a precipitation reaction. The final product will be a solid. Look, it is important that you write the subscripts using this symbol. And also the solid is supposed to be as a subscript. Then you have this symbol, you press this, and you have the solid. And you begin from aqueous ions. Then you have manganese 2 in aqueous solution. Then you have to press the symbol aqueous as subscript. And you have to put 2 hydroxide because hydroxide is -1. As you have 2 positive in manganese, you need 2 negative ions to balance the charges. And you write a 2 in front of the ion. The charges are represented present this symbol because they will be like an exponent. And the aqueous is represented by this symbol, but as a subscript. the arrow, and then the compound that you had. Remember that the OH in this case contains 2 hydroxide, and it is as a subscript into parentheses of this compound anion. And the symbol of solid, this one, will be as a subscript using this. If you don't use this, these representations, then even though you use the correct numbers or symbols, you are wrong. Then many of you had problem because you didn't use correctly. You didn't plug the symbols in the correct form. Here you have another example. The compound magnesium sulfide, look, is a solid. And when it is a strong electrolyte and it is soluble, then you have to represent as the ions. Magnesium is +2 because it belongs to group 2, and the SO3 sulfide anion is -2. You can have this from a list of the compound anions and cations. And then you get the ions in aqueous solution. Remember that aqueous is supposed to be as a subscript. Here is a similar exercise. In this case, you have 2 bromides, then you have to write a 2 in the front, -1 because bromide belongs to the group 7A, that the charge almost always is -1. And as they say that is copper 2, the charge will be +2. And of course, this compound is a strong electrolyte and is soluble, then you have to put in aqueous solution. In this case, they are asking for the net ionic equation for this molecular reaction. The first step that you are supposed to do in your notebook is to write, if it is soluble, then you divide this in 2 parts, the cation and the anion. And here the same thing, is soluble, then the cation and the anion. As this compound is a solid, remains as a compound. You cannot divide this into ions since it is a solid. This is soluble because it's in aqueous solution, then you divide this into ions. And then you cancel out the ions that are the same in the products than in the reactant. This is the case of nitrate and ammonium. They are spectators in the reaction. They remain the same in the reactants than in the products. But the net ionic equation then will be represented by the baryon reacting with the carbonate to form a solid. And that's what you write here. You leave empty the last box because you don't need it. In this case, you have to represent the net ionic equation for the precipitation of manganese hydroxide. Then, all what you have to do is to begin from the cation manganese plus 2, because it's manganese 2 in aqueous solution, plus 2 hydroxide, because the hydroxide is -1. So you need 2 hydroxide per 1 manganese, that is +2, in order to balance the charges of this compound. Both are in aqueous solution, but when they react, they yield a solid. Remember that the symbol of solid and the 2 in hydroxide are subscripts, and you need to press this symbol to block the 2 and the solid symbol. Here you have to write the balance equation for the combination of a carbon monoxide and oxygen to produce carbon dioxide. Remember that you have to balance the equation. If you don't balance the equation, then the answer will be incorrect. For example, here, this answer is incorrect because it is not balanced. This is the right answer. Then, as you can see in this type of exercise, you have to know how to write the symbols of a cation and an ion, and the symbols of a compound. And also you must know how to write an equation. And also you must know how to balance the equation. And also you need to know the solubility rules. Then in this type of exercise, you have many things that you learned before together in one exercise. Here is the decomposition of hydrogen peroxide into water and oxygen. This is a representation. You cannot write this way because this equation is not balanced. Then will be incorrect. Here you have another example. They ask you, does a reaction occur in aqueous solution for potassium hydroxide and sodium nitrate? You say, well, sodium nitrate is soluble. Potassium hydroxide is soluble. It is a double displacement reaction. Sodium will combine with hydroxide to form sodium hydroxide, and potassium will combine with nitrate to form potassium nitrate. In all the cases, the ions will remain in aqueous solution. So there is not a solid, there is not a gas, and this equation is considered that doesn't happen. There is no reaction. There is no reaction at all. In this case, you have a net ionic equation because one of the compounds that is formed by calcium and sulfide is calcium sulfide, that is a solid. And then remember the solubility rule that says that sulfides are insoluble almost all the time. Then in this case, you have not a net, you have a net ionic equation since calcium sulfide is non-soluble. Well, I think that I clarify most of your doubts. If you still have problems, please don't hesitate. Send me an email and I will explain you your doubts.